Hello students and good afternoon. So now I am doing class for class 12 science. The topic is integration of some special form of functions. And in the last online class also we were doing the same chapter, that is integration of some special form of function. So today is the continuation class for this chapter. Same exercise, exercise 8, 2 mark section, page number 396 from the book Higher Mathematics of class 12 by Sailendra. Okay, so let's do this question number 10 now. So let us integrate. That is, it is given, the question is integral sine to the power 4x cos to the power 4x dx. So in the last online class I already told you about the method how to integrate these functions. So here also we have got both the functions sin x as well as cos x, and both the powers are even powers. So if both the powers are even powers, then you should convert into multiple angles form. So same powers are there, sin 4x cos 4x dx. So in this case we can use the formula 2 sin x cos x, which is equal to sin 2x, right? But since both the powers are 4 here, so let us write I is equal to integral sine, let us write here 2 sin x cos x whole to the power 4 dx. So we are writing here 2 sin x cos x, so that you can use the formula of 2 sin x cos x is equal to sin 2x. You know the formula, isn't it? So if you write 2 whole to the power 4, it will be 16. But is there 16? No, you have to cancel it. So before integral sign you should write 1 by 16. So before integral sign you write 1 by 16, so that this 16 and this 2 to the power 4 will be cancelled, and you will get the same question, that is integration of sin to the power 4x into cos to the power 4x dx. Okay, so let us use the formula now, or I is equal to 1 by 16 integration of this is sin 2x whole to the power 4 dx. Or I is equal to 1 by 16, this is integration of sin to the power 4 2x dx. Again here the power is even power. Again you have to convert to multiple angles form. That is, now in this case we should use this formula 2 sin square x, which is equal to 1 minus cos 2x. Okay, now since there is sin to the power 4 2x, you should write it in the form of 2 sin square x form, right? So or I is equal to 1 by 16 integration of, let us write here 2 sin square 2x whole square, then you should write dx here. So if you simplify it, 2 sin square 2x whole square is 2 whole square is 4. It will be 4 sin to the power 4 2x. Sin to the power 4 2x is correct, but is there 4? Is it 4 sin to the power 4 2x? No, you should cancel it. So in the front you can write, into 1 by 4, or this is I is equal to. So I hope you have understood it. Okay, or I is equal to, this is 1 by, this 2 whole square is 4, you have to cancel it. So you write 1 by 4 out here, so that 4 will be cancelled. Okay, so 16 4s are 64. Now it is integration of, what is 2 sin square 2x? 1 minus cos, what is double of 2x? Double of 2x is 4x. Since 2 sin square x here is 1 minus cos 2x, you can write 2x as 4x. So it is 1 minus cos 4x whole square dx. Is that understood now? So let us use the formula here. This is a minus b whole square. That is a square minus 2ab plus b whole square. Or I is equal to, this is 1 by 64 integration of, within bracket, what is a whole square? 1 minus, what is twice ab? It is 2 cos 4x plus, what is b whole square? It is cos square 4x bracket closed dx. Okay, that is a square here is 1 whole square is 1. Minus twice ab minus 2 cos 4x plus, what is b whole square? It is cos square 4x bracket close, then you should write dx, right? So let us separate the term now. or I is equal to, what is the first term? 1 by 64 integral sine 1 into dx is dx, 1 into dx is dx, minus 2 1s are 2, 2 3s are 6, 2 2s are 4, isn't it? Now you can cancel this 64 by 2, that is 2 1s are 2, 2 3s are 6, 2 2s are 4, that is 32. 1 by 32 integral sine cos 4x, that is cos 4x dx, right? So in the next step, you know this formula, right? Minus 1 by 32 cos 4x dx, and what is the last one? Plus 1 by 64 integration of, now this is cos square 4x dx. It is cos square 4x dx. So I hope you have understood it, okay? For the first two terms, you can easily integrate them by using the formula. Or I is equal to, this is 1 by 64 into x minus 1 by 32 into, what is integration of cos 4x? That is sine 4x divided by 4. Now in this case, since there is cos square, you should multiply and divide by 2. Plus, this is 1 by 2 4s are 8, 62s are 12. Integration of this will be 2 cos square 4x dx. Right? So, or I is equal to, this is your x by 64 minus sine 4x by 4 2s are 8, 4 3s are 12, 128 plus 128 integration of, what is the formula here? You know that 2 cos square x is equal to 1 plus cos 2x. Double of x is 2x. But here it is 1 plus cos, what is double of 4x? It is 8x, bracket close, then you should write dx, okay? Or I is equal to, this is x by 64 minus sine 4x by 128 plus, let us separate the term, 1 by 128 integral sine 1 into dx dx plus 1 by 28, 1 by 128 integral sine, this is cos 8x dx. Is that clear? Next, or I is equal to, this is x by 64 minus sine 4x by 128 plus, what is integral sine dx? X divided by 128 plus 1 by 28 into, what is integration of cos 8x? It will be sine 8x divided by 8 plus c. Is that clear? Now in this case, you can simplify these two similar terms. Both the terms contain x, these are similar terms, you can simplify it. Or I is equal to, now between this, among this 64 and 128. Now what is the LCM of 64 and 128? This is 128. This 128 is divided by 64, that is 2 times 2 into x is 2x plus 128 is divided by 128, so it is 1 into x is x, right? Then minus sine 4x divided by 128 plus, this is sine 8x divided by, let us multiply 128 by 8. 8 8s are 64, 4 6. 8 2s are 16 plus 6 is 22, 2, then 2, 8 1s are 8 plus 2 is 10, then you write plus c. Or now this is I is equal to 3x by 128 minus sine 4x by 128 and plus, what is the third term? Sine 8x divided by 1024 plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we will do the next question. So now we'll do the next question, that is question number 11. So the question here is integration of sine 3x into cos cube x dx. So now in this case, first of all, use the formula of sine 3x. You know the formula of sine 3x, isn't it? So let us use the formula first, then let's see what method is to be used in this particular integration. Okay, so let us first write I is equal to integration of sine 3x into cos cube x dx, right? So or I is equal to integration of, what is the formula for sine 3x? It is 3 sine x minus 4 sine cube x, isn't it? What is the formula for sine 3x? You should know it. It is 3 sine x minus 4 sine cube x. You have done it in multiple angles in trigonometry. Sine 3x is equal to 3 sine x minus 4 sine cube x, bracket closed. Then you write cos cube x dx. Now what will you do? Since you know that this is in terms of sine x and this is in terms of cos cube x. So if you can break the odd power, that is, I already told you that whenever there is odd power, this odd power can be broken as cos square x into cos x. And cos square x is equal to sine x. Then you can assume sine x as z, so that the differentiation of sine x is cos x. We can do the method of substitution. Is that clear? So let us separate cos cube x. I is equal to integration of, within bracket, this is 3 sine x minus 4 sine cube x, bracket closed. What is cos cube x? It is cos square x into cos x dx, right? So or I is equal to, this is integration of, within bracket, 3 sine x minus 4 sine cube x, bracket closed. And what's about cos square x? It is 1 minus sine square x into, this is cos x dx. Now these two factors are in terms of sine x and there is cos x dx. And you know that the differentiation of sine x is cos x. So let us assume these sine x as z. Okay, so let z is equal to sine x. Now since this is the method of substitution, that is z is equal to sine x, you have to differentiate both the sides with respect to x. Okay, so differentiating both the sides, with respect to x. Therefore dz by dx is equal to cos x. So let us do cross multiplication. Dz is equal to, this is cos x dx. So dz is equal to cos x dx, right? So now what is I? So therefore I is equal to integration of, within bracket, this is 3z minus 4z cube, isn't it? So instead of sine x, you put z. So 3z minus 4z cube, bracket closed. Then within bracket 1 minus z square, isn't it? So this is 1 minus z square, bracket closed. And then what's about cos x dx? It is dz. So this is your dz, right? Now let us multiply these two factors, or I is equal to integration of, within bracket, 3z into 1, 3z minus 3z cube, isn't it? Minus 3z into z square, 3z cube, minus, this is 4z cube into 1 is minus 4z cube, minus into minus plus 4z cube into z square is z to the power 5. If you multiply z cube and z square, the powers will be added and you'll get 4z to the power 5. Is that clear? This 3z into 1, 3z into z square minus 3z cube minus 4z cube minus into minus plus 4z to the power 5. Then what should you write here? dz. Okay. Similar terms can be simplified here. I is equal to integration of, this is integration of, within bracket, this is 3z minus 7z cube, same sign can be added, then plus 4z to the power 5, bracket close, dz. Is that clear? Now let us separate the term, or I is equal to, this is 3 integration of z dz, right? minus 7 integration of z cube dz, right? Then plus 4 integration of z to the power 5 dz. So we have separated this integral sign and dz also. Now you can easily integrate them. This is just like integration of x to the power n dx, which is equal to x to the power n plus 1 divided by n plus 1, or I is equal to 3 into z square by 2 minus 7 into this is z to the power 4 divided by 4 plus 4 into this is z to the power 6 divided by 6. Then what do you write? Plus c. So here you can cancel 2 2s are 4, this is 2 3s are 6, put the value for z, or I is equal to this is 3 by 2 into what is z square here? What is z? Sin x. So this is your sin square x minus 7 by 4. If you put z as sin x, you will have sin to the power 4x. This is your sin to the power 4x plus this is 2 by 3. What is z to the power 6? It is sin to the power 6x. Then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do this question number 12. The question is integration of sine 2x sine to the power 4x dx. So how can you do this integration? So you know the formula of sine 2x. What is sine 2x? 2 sine x cos x. Let us write it. So therefore I is equal to integration of what is sine 2x? This is 2 sine x cos x into this is sine to the power 4x dx. This sine to the power 4x is kept as it is. You just write down the formula for sine 2x, which is 2 sine x cos x, or I is equal to integration of, now this is 2 sine x into sine to the power 4x. This is your sine to the power 5x into cos x dx. And since here 2 is constant, take it outside. This is 2 integration of sine to the power 5x into cos x dx. So now what is the method for integrating it? This is your sine to the power 5x into cos x dx, and differentiation which function is cos x? Sin x, isn't it? So we can assume this sin x as z. So let z is equal to sin x. Let z is equal to sin x. Okay, so let us differentiate both the sides. Differentiating both the sides with respect to x. So what do we get? That is dz by dx is equal to, what is here? This is cos x. Now let us do cross multiplication. Dz is equal to, this is your cos x dx. So we have got the value for cos x dx, which is equal to dz. So what does I become now? Therefore I is equal to, this is 2 integration of what is sine to the power 5x? It is z to the power 5. It is z to the power 5. Okay, and what's about cos x dx? It is dz. So let us write here dz, right? Or I is equal to 2 into what is integration of z to the power 5? Z to the power 6 divided by 6. Then what do we write? Plus c, because we have finished integration, right? So here you can cancel 2 1s are 2, 2 3s are 6, or I is equal to 1 upon 3 into, let us put the value for z. What is the value for z here? It is z is equal to sin x. So this will be sine to the power 6x plus c. So this is the final answer. So I think you have understood it. So similarly, I will give you the problem. Similar problem is there. Let us mark it as extra mark because this is not from the book. So this is your homework. So integration of sine 2x. Integration of sine 2x, and instead of sine to the power 4x, it may be cos to the power 4x dx. Instead of sin to the power 4x, it may be cos to the power 4x dx. So this is your homework. Okay. So now you can copy it. Now we will do the next question. So now we'll do the next question, that is question number 1 from the section 4 marks section. So we have finished 2 marks section. We have finished problems from 2 marks section. So let's do problems from 4 marks section now. So let us integrate. Question number 1. Integration of cos 2x sin cube x dx. There is also odd power for sin x, sin cube x. Let us break the term as sin square x into sin x dx, right? So therefore I is equal to integration of, this is cos 2x into, this is your sin square x into sin x dx. That is, sin cube x is separated. Sin cube x is separated as sin square x into sin x. And you know that the differentiation of cos x is minus sin x, isn't it? So let us convert this sin square x into cos x and this cos 2x in terms of cos x. So now you know the formula of cos 2x in terms of cos x. It may be cos square x minus sin square x, right? And cos 2x is equal to 1 minus 2 sin square x. And cos 2x is equal to, this may be 2 cos square x minus 1. Okay? Or I is equal to integration of, since you know that the differentiation of cos x is minus sin x, you should get sin x dx. So let us convert this sin square x into cos square x and this cos 2x in terms of cos x. What is cos 2x in terms of cos x? It is 2 cos square x minus 1, right? Cos 2x is what? 2 cos square x minus 1. And what's our sin square x? 1 minus cos square x, bracket closed. Then what should you write here? It is sin x dx. So I hope you have understood it. So let us do the method of substitution. Which function is taken as z? Here the differentiation of cos x is minus sin x. So let us assume z is equal to cos x. So let this is z is equal to cos x. So write down differentiating both the sides. Differentiating both the sides with respect to x. So it is dz by dx is equal to minus sin x. Let us do cross multiplication. Dz is equal to minus sin x dx, and minus sign is taken to the left hand side. So this is minus dz is equal to, this is sin x dx. So we have got the value for sin x dx, which is equal to minus dz. So therefore what is I now? Therefore I is equal to integration of, within bracket, cos x is z actually. So it is 2z square minus 1. 2z square minus 1, right? 1 minus z square. 1 minus cos square x is z square, right? And what's about sin x dx? Minus dz. Into, you can write minus dz. Okay? Now let us simplify it first. Let us simplify it. Or I is equal to minus sign is taken outside, integration of within bracket. Let us simplify it. Let us multiply these two factors, 2z square into 1. 2z square minus sign is there, 2z square into z square, 2z to the power 4. This is minus 1, minus into minus plus, z square, bracket close. Then what do we write here? dz. Is that clear? 2z square into 1, 2z square minus 2z to the power 4, minus 1 into 1 is minus 1, minus into minus plus z square. So, or I is equal to minus integration of within bracket 2z square plus z square is, this is your 3z square. This is minus 2z to the power 4, then minus 1, bracket close, dz. So let us separate the term now. Or I is equal to, what is it now? minus 3 integration of z square dz, minus into minus plus 2 integration of z to the power 4 dz, minus into minus plus what? Integral sign dz. Integral sign dz. Okay? Or I is equal to minus 3 into what is integration of z square? Z cube by 3 plus 2 into what is integration of z to the power 4? Z to the power 5 by 5. And what is the last term? Plus z plus c. So let us put the value for z now. So here you can cancel this 3 gets cancels, or I is equal to minus, what is z cube? Cos cube x. Since z is equal to cos x is here, what is z cube? Cos cube x. Then plus 2 by 5 cos to the power 5x, that is z here is cos x. Cos x whole to the power 5 is cos to the power 5x plus what is z again? Z is equal to cos x. Cos x, then what do you write? Plus c. So this is the final answer. So you can copy it. Now we'll do the next question. So now this question number 2 from the book is your homework, that is integration of root over sin x into cos cube x dx. Here also this is odd power cos cube x, the power of cos x is 3, that is odd power. You can break this term as cos square x into cos x, then since cos square x in terms of sin square x, that is within bracket you can write 1 minus sin square x, and there is cos x dx. So you can assume sin x as z because the differentiation of sin x is cos x. So this is your homework number 2, right? So let's do this question number 3 now. So here the question is I is equal to integration of sin x dx divided by cos 2x. So how can you integrate this function? So there is sin x in the numerator. There is sin x in the numerator. So what is the differentiation of which function is sin x? It is cos x, isn't it? So you have to express cos 2x in terms of cos x. And you know the formula of cos 2x in terms of cos x, isn't it? That is cos 2x in terms of cos x is cos 2x is equal to, this is 2 cos square x minus 1, right? So here let us write I is equal to integration of, this is sin x dx divided by, this is your 2 cos square x minus 1. Since we have changed this cos 2x in terms of cos x, because you know that the differentiation of cos x is minus sin x, because in the numerator sin x is given. So that's why this cos 2x is written in terms of cos x. So what is the formula for cos 2x in terms of cos x? It is 2 cos square x minus 1. Okay, and you know the differentiation of cos x is minus sin x. Okay, so let us write it as I is equal to integration of sin x dx. Here you can write it as within whole square root over 2 cos x whole square minus, you can write it as 1 whole square. Okay, since the coefficient of cos square x is 2, so that's why you can put this 2 cos square x within whole square, and you can write it as root over 2 cos x whole square. And since the coefficient of cos x here is root 2, let us assume root 2 cos x as z. So let z is equal to, this is root over 2 cos x. Okay, so let us differentiate it. So differentiating both the sides, with respect to x. So this is dz by dx. So it is dz by dx is equal to minus root 2 into sin x. You know that the differentiation of cos x is minus sin x. Okay, let us do cross multiplication. So it is dz is equal to minus root 2, this is sin x dx. But in the numerator we have sin x dx there. So minus root 2, take it to the left hand side. So it is minus dz upon root 2 is equal to, this is your sin x dx. So we have got the value of the numerator, that is sin x dx is equal to minus dz by root 2. Okay, so let us put it in I. So I is equal to integration of, what is sin x dx? It is minus dz by root 2, this whole divided by, what is root over 2 cos x? It is z square. This is z square minus 1 square. Okay, or I is equal to, which constant is taken outside? This is minus 1 by root 2. Minus 1 by root 2 integration of dz divided by z square minus 1 square. It is minus 1 by root 2, then integration of dz divided by z square minus 1 square. Now this is the standard form from method of substitution. Now we can use this formula. Integration of dx divided by x square minus a square. What is the formula? This is just like your integration of dx divided by x square minus a square. What is the formula? 1 by 2a log within mod x minus a upon x plus a mod sign close plus c. Here the base is e. You can use this formula, right? So or I is equal to minus 1 by root 2 into, what is the formula? 1 by 2 into a, here is 1, x here is z. 1 by 2a log within mod, what is x minus a? That is z minus 1. What is x plus a? Z plus 1 mod sign closed plus c. Here the base is e. Okay, or I is equal to, what is here? Minus 1 by 2 root 2, minus 1 by 2 root 2, right? Then log within mod, here the base is e. Let us put the value for z. What is z here? Root 2 cos x. It is root 2 cos x minus 1, root 2 cos x minus 1 divided by root 2 cos x plus 1 divided by root 2 cos x plus 1 mod sign closed plus c. So this is the final answer for this question number 3. So I think you have understood it, so you can copy it. So I'll give you a similar type of problem, that is your homework, but that is not from the book, right? That is integration of, it may be cos x dx in the numerator divided by cos 2x. So this is your homework. You can do it at home. That is integration of, instead of sin x there is cos x dx and the denominator remains same, that is your cos 2x. So you can do it at home. And you know that differentiation of which function is cos x? It is sin x. You have to express cos 2x in terms of sin x, right? So you can write it as cos 2x is equal to 1 minus 2 sin square x. So instead of cos 2x you have to write 1 minus 2 sin square x. Okay, so you can do it at home. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 4. Let us integrate this function sin square x divided by cos to the power 6x then dx. So let us write first I is equal to integration of sin square x dx divided by cos to the power 6x. Okay, so now let us simplify it first. Okay, or I is equal to integration of, you can write it as sin square x by cos square x. Okay, since there is sin square x, so you should divide it by cos square x, but there is cos to the power 6x, you can write it as 1 upon, this is cos to the power 4x dx, right? So, or I is equal to integration of, what is it? What is sin square x by cos square x? This is your tan square x. What is 1 by cos to the power 4x? It is sec to the power 4x dx. Is that clear? Next, so how will you evaluate this integration now? You know that the differentiation of tan x is sec square x, isn't it? The differentiation of tan x is sec square x. So let us break the term sec to the power 4x, or I is equal to integration of this is tan square x into, you can break it as, you can separate it as sec square x into sec square x dx. Okay, and you know that the differentiation of tan x is sec square x. Okay, let us change one of these sec square x in terms of tan, or I is equal to integration of tan square x is kept as it is. What is sec square x? One of these sec square x is changed into tan square x, that is, you know, 1 plus tan square x into, this is sec square x dx is kept as it is, right? So now let us do the method of substitution now. Now which function is taken as z? And you know that the differentiation of tan x is sec square x. Let us assume tan x as z. So let z is equal to tan x. So let us differentiate it, differentiating both the sides with respect to x. Okay, so we are differentiating both the sides with respect to x. So therefore dz by dx is equal to, this is your sec square x. Now cross multiply, dz is equal to, now this will be sec square x dx, right? So let us put these values in I. Therefore I is equal to integration of, what is tan square x? It is z square. Within bracket, what is 1 plus tan square x? It is 1 plus z square, bracket closed. And what's about sec square x dx? It is dz. Is that understood? So now you can multiply and separate them, or I is equal to integration of, this is z square dz plus integration of z square into z square, z to the power 4 dz. Now let us integrate it. I is equal to, what is integration of z square? Z cube by 3 plus, what is integration of z to the power 4? Z to the power 5 divided by 5 plus c. Okay, what is integration of z square? Z cube by 3. What is integration of z to the power 4? Z to the power 5 by 5. Now let us put the value for z, or I is equal to, what is z actually? Z is tan x. So it is tan cube x divided by 3 plus tan to the power 5x divided by 5 plus c. So this is the final answer. That is, what is the answer here? I is equal to tan cube x divided by 3 plus tan to the power 5x divided by 5 plus c. That is the final answer. So I think you have understood it. So today also we did some problems in this chapter, that is integration of some special form of functions. So this much is for today. So you revise all the problems that we did in this chapter, and in the next online class we'll do more problems on this chapter. So this much is for today.